Hi there, my name is Will, and today I'm going to walk you through how to set up your very own ETL pipeline with Kestra using Postgres. Now for this example, we have a bunch of data available on the New York taxis. We've got a yellow data set and we've also got a green data set. Now we're going to look at some of this data and then perform some operations on it using Kestra to then put it into a database. Now you can see here that this data set is split into months, and so it's fair to assume that every month we will get more data. And as you can see here, we've got data for all of 2019, 2020, and up to July of 2021. And so what we can do is create a workflow that is going to process this data each month and add it into a table that combines it all together. This saves the hassle of having to go and download the data myself each month and then add it in. So let's jump into Kestra and begin building this workflow. Here I've created a simple workflow called Postgres Taxi within the namespace Zoomcamp. Now, to begin with, we're going to need to create a number of tasks to perform ETL. To begin with, we're going to need to extract the data from this Git repository, which we can do by making a request to the repository. Then we want to transform the data. In this scenario, what we're going to do is merge it into a table that has all of the data. First, we're going to extract the data from GitHub, and we can do that making a request. Once we've extracted the data, we can then load that into a table in a Postgres database, and we can then combine that with a main table that's got all of the data from the different months. Now, we are going to need to create a Postgres database, but we'll come back to that in a second. To begin with, let's focus on extracting the data. Now, because I mentioned that there are two types of taxis, we're going to create an input here to allow us to filter between green taxis and yellow taxis. I can do that by typing in inputs, and I can simply make it a drop-down select with either yellow or green. So now, if I run this workflow, you'll see I get the option of yellow and green. What we'll do is we'll set that to have a default value of yellow, and we can also add a display name to make it a little bit easier to understand what's going on. So now when I press execute, we can see here at the top, it tells us which taxi type we'd like to select, and yellow is selected by default. Let's replicate that as well so we can define which month we want to select and which year. As you can see, all of the data sets here are split into month and year. So now I've got another input here that's going to give us a drop down with the year, and we've also got one with the month. So if I press execute, we've now got the years and the month, so we can get all of that data available. Now that we have this available, we can now form a request to be able to get exactly what we're after. So we can say we want 2019-01 or, of the yellow data set, or we can ask for the green data set too. And so here you can see we've got all the green data as well. But there's a few things we can do to make that a little bit easier. Because we've got all these different input values that are going to change at every execution, and we want to be able to form file names and table names, we can actually create variables that are dynamically generated based on these inputs. So let's create those and show you how you can then dynamically render those as well. So you can see here, I've now got 4 different variables. I have file, which is the file that we're going to try and download. We've got our staging table. This is the table that we're going to load with the monthly data, the data from our file. We've got the table that's got all of the data in it. This could have multiple months worth of data. And then we've got the data itself, which as you can see is generated based on an output from that extract task, which we haven't quite added yet. So let's go and create the extract task so we can start extracting it, and we can use the new file variable that we've made here that's going to have which type of data, the year and the month. .csv, which we can see here is exactly what we're after here. I've also added a quick set label task here just to be able to help us identify if this is a green taxi or a yellow taxi execution. So we can easily spot at a glimpse which one it is. Now underneath, I've got an extract task, and here I'm just using a shell commands task here to be able to just run a command using wget to be able to pull that file from GitHub and unzip it, because as you can see, it is in a .gz file format, which means that it is compressed. So we need to uncompress it so we can use the file, and this will generate us a CSV file that we'll be able to use. If I execute this now and I select green of 2019-01. For context, green is smaller than yellow, so it's a bit quicker. If I press execute here, you'll see that it's going to run that extract. And it's going to take a little bit while to download it, but if I go to output, we'll be able to see that I now have a file here that I can preview with all of that data in it ready to go. And so we're now ready to be able to start putting that into a table. But In order for us to put it into a table, we need to create a database. Kestra itself runs on a Postgres database, so we could use that, but I'm going to show you how to quickly spin up your own Postgres database using Docker. I've created a simple Docker Compose file here that has got a Postgres database in it. So as you can see here, we've got a service called Postgres. It's got the image Postgres, and I've just called my container Postgres DB. I've given it the same username and password as the Kestra one, but changed this to whatever you'd like. And the database itself is called Postgres-Zoomcamp. This is going to run on the default port, so I can easily run this now by just running docker compose up. And this is now going to turn on our database. We can see that it was already existed and it's running now. So now we'll be able to connect this with Kestra and start reading and writing data to it. So what I can do now for the green data set is I can now add a Postgres queries task here where I can say if the table does not exist, the table being vars.table being public dot, and then the color of the taxi, in this case, green underscore trip data. So the main table with all the combined data is going to be called the color of the taxi underscore trip data. And our staging table is the same, but with underscore staging at the end. Now, the reason we have to use this render function inside of this expression is because we need to be able to render this variable, which has an expression in it. So we get a string, which will contain green or yellow, and then we can use it. Otherwise, we will just receive this as a string like it is in the format we see right now, and it will not have the dynamic value inside of it. So when you're doing a recursive expression where you've got an expression that's calling a string that has an expression in it, you just need to make sure that you explicitly tell it to render that too. This looks quite similar to the dataset. It's not quite the same, but it's got two extra columns here. We've got unique row ID and file name. So we can see which file the data came from, but we can also give it a unique ID that is generated using an MD5 hash so that it's generated based on the data in that row, but it means that we can prevent adding duplicates later. There's nothing worse than if we rerun the same month and it tries to add all that data back into the table despite it already being there. But if there are some gaps, it will still add those gaps back in, because the MD5 hash will not exist in the table. Let's have a look at what the data looks like if we were to download the CSV raw. One thing we do need to add though is for the SQL task to work, you'll see that it's going to need a URL and the information for the actual database. Now, because we're going to make a few queries here, we're going to use something called plugin defaults to allow us to be able to set the URL, username and password for all Postgres tasks without having to constantly copy and paste it. This is useful if we end up using a different database with a different connection URL and we haven't got to update it in all the locations. As you can see, I've added plugin defaults at the end here for the Postgres plugin, and we can see that I'm using host.docker internal because it's running Docker as is Kestra, so it means that it can see itself. On the correct port number, the username and password, as you can see, match what we have inside of our Docker Compose file. So now if I press save, we will be able to run this task and see it create a table. But first, what we're going to do is actually go over to the file of green taxi data and have a look at what that looks like. So here is the CSV file. As you can see at the top here, we've got all of those different properties that we saw inside of the schema, which we can see here by pressing edit flow. And if we scroll down, we can see that these are all the same columns that we're going to expect from the green table. Now we are going to have to create a separate task here for the yellow one because the columns are slightly different, but we'll get onto that in a minute. What we'll do is we'll go through the green one entirely first, and then we'll create a yellow one, and we can then use an if statement to decide which block it's going to run to make sure we're running only what we need. Now we've got a task that will create our table. We also need to create a staging table where we can put the data in from the CSV file and then use that to then merge it into the main table. This is the table that we'll also use to add those additional columns as well, which will have the unique ID and the file name that don't already exist inside of the CSV file. So what we'll do now is create a new task to create the staging table, and then we can start to copy the data in. So now we've got an extract. we're going to create our main table, and then we're going to create our staging table. And as you can see here, the staging table looks very similar to that main table. We're going to truncate this table to remove all the data out of it, and then put new data for each time we run this with a different month. So this table is not the final product. It's just so we can use it to create those new columns. So now that we've done that, what I can do is if I press execute, we can then see it create these tables in the database and check that using pgAdmin to be able to double check that we've done that correctly. Now, if I scroll over to the side here, I've got pgAdmin ready to go. Now, what I can do here is I can add a new server. I've already got mine connected, but all we need to do, and I can actually show you what mine looks like. So you can see here, I've just put localhost as my connection. I've put the port number. The name of it is Postgres Zoomcamp, and then I've put my username and password in. Once you've done that and press save, it should automatically connect. And if we go all the way down under schemas, we'll be able to find a tables property. And as you can see here, we do not have any tables currently. So if I go back over to our workflow and press execute, and we're going to do it for the green taxi of 2019-01, what we should see is it's going to now run this and create those tables. So we'll just have to wait for it to do that. We can see that it's now created both of those tables. And if we come back here and click refresh, we will see that we now have two tables on the side here, green trip data and green trip data staging. And we can now use these to actually process the data. So, but we can also view them. So we can see that there's currently no data inside of it. And we can do the same for the other one as well. Again, no data inside of either of these. So with that in mind, let's now jump back into Kestra and add some more tasks to take the data from our CSV file and put it into the database. So you can now see in the topology view, we're going to copy the data into the staging table. So if I now run this again using the green data set, we're going to see that this is now going to move that data into it. And so when we go to pgAdmin, we'll be able to actually see some data there. So now if I was to rerun this query, and we'll do that here for all the rows, you'll see now we've got all the data in those CSV files, and there are now 630,000 rows. So we know that this is working as expected. But the unique row ID and file name columns are null because we haven't created these values yet. That is what we'll do in a second. And you can see here with the staging task, we're using the copy in task in Kestra. We're saying we want it from our data, which we have to render because the data is an expression itself. We can see here that the data is actually an output with some extra bits inside of it. So we need to render that as a string so it knows what it's looking for, which is the name of the output file with some of that additional data inside of it. And then on top of that, we need to specify what columns we're going to write to, which is why that unique ID and the file name were left as null because we weren't writing to those just yet. And then we've just specified the name table that we want to write in. So if I was to actually run that again on the normal table, we'll see still no data in here yet. We can be pretty happy that this has worked correctly. What we're going to do now is update those additional columns to be able to add our unique ID and our file name. So here, those columns already exist, so we don't need to alter the table. And as you can see, it already automatically just left it as null, so we don't have to do anything there, which is handy. Now, what we're going to do is put update and specifically update our staging table, again, using that render function to be able to get our dynamic variable in a string format so that it actually has the full name of the table. And then we're going to set that unique ID as an MD5 hash. And as you can see, we're passing in a lot of the data that's inside of that row to make sure that we can generate the same MD5 hash with the same data from a different file. So if we end up reusing the same file, it's always going to create the same one. Whereas if we just generated a random UUID, for example, it would get different unique values every time we run it, and we'd get duplicates, which is not what we want to do here. So this will help us prevent getting any duplicates inside of our database. And at the bottom here, file name is just simply the name of the file, and we're just rendering that again because the original variable had expressions in it. So now if I run this again using the green data set, we're going to see here that it's going to get that data and it's going to put it into the database. And we can see it's adding those extra 2 columns worth of data. So we'll be able to see in a second, those columns will have populated. So now if I go back to the staging table and run this again, we can now see that the unique row ID and file name are populated. But the eagle-eyed viewer here might have noticed a problem. You might have noticed our row count has doubled because what we've done is just add the same file to the same database. We haven't actually cleared it before writing to it again. And so we need to take a step backwards for a second and add an extra task just to clean this up. Just to interject, there is actually one thing we do need to change. As we can see here, for when we add the unique ID and file name, we're making a great assumption that vendor ID exists every single time. However, if we have a quick look at pgAdmin, we can see that vendor ID is null for a bunch of different cases, and we can actually see that as well in VS Code too. As you can see here, we've got numbers in that first column, but if I scroll down a little bit further, you'll see that they will start to disappear, which doesn't help us very much when we're trying to generate a unique value based off of them. As you can see, they're all gone now. So what we need to do is actually add another null coalescing operator in here to be able to account for the fact that it might be null. What we can do here is just simply add it in here, wrap it in coalesce, just like we have for the rest of the values, and that will cover us. But we'll need to make sure we do that for the green one as well to cover our bases there. Now we can rerun this and know that we're going to get the unique value, because without the unique row ID here, we're going to end up with duplicates. So it's important that we do have a value in the vendor ID. Otherwise, we're not going to be able to prevent duplicates. So before we add any data to this table, we need to truncate it, which will remove all of the data from the table, but leave the columns and the table itself intact. This is a little different from dropping a table, which will just get rid of the table from existence. It just removes the data from it. So now we can want one extra query here before we start copying data that's going to truncate our staging table. But it's worth noting that we're never going to truncate the actual table, because that will never have duplicates based on the merge that we'll do a little bit later. So now if we execute this again, what we'll see is we'll lose all of those rows, but we'll continue having the unique values where we wanted them. So we can see now that it's going to copy the data in and it's going to add the unique values in. But when I then check again inside of pgAdmin, you'll see that now the row count is what we had originally. So we know that it's not adding duplicates again. That means there's only one thing we need to do now, which is merge the data from our staging table into our main table to get a complete data set. So we're now happy that all the data in the staging table is in the format we would expect. It's got a unique ID. It tells us which file it came from. Now all we need to do is now add it to the trip data table, and then we can run that again and again for different months to be able to get a bigger picture. So all we need to do now is press edit. We'll scroll down to the bottom here. So now we're going to merge into the table, which we refer to as T, using the staging table, which we refer to as S. And what we're doing here is then checking that the unique row ID in our actual table matches the staging table's unique ID too, which means that when they're not matched, it's going to insert. But if they are matched, we're going to discard that row, which means if I keep running January multiple times, we're not going to see multiple duplications inside the table. And we can see here that it's going to insert on for those specific columns that we have, and we're going to use the data from the staging table. So now let's execute this for the green data set, and we'll be able to see that we now have data in both the staging table, but also of the final table as well. And we can see now it's merging that data in quite nicely for us. If I now go back to our normal table, which we can see previously was empty, if I run this, we're going to see that this has now got those 630,000 rows. What we're going to do now is run this again for the green data set for February, and we'll now see that the staging table will get truncated. We'll then add the February data into that, and then we'll merge it into the main table, which already has January ready to go. And because the January data and the February data is different, they'll have different unique IDs, and we will not then see any clashes. So now we've merged that all in. So now if I go to the staging table and run this again, we're going to get a different number here, 575,000 rows rather than 630,000 rows. So that means if I run this again, we should see the number should nearly double, 1.2 million rows. As we can see, we've got all the January data. If I go to the last page, we can see that that's got February data in it too. So what we've done here is we've extracted the data from GitHub. We've then put it into a staging table where we can add a unique ID and the file name as extra columns to the original data. We've then merged that data into the main table so we can create a table that's got everything inside of it rather than having all these separate files. So now we've done that for the green data set. Let's now do it for the yellow data set and create a little bit of conditional logic to make sure our workflow knows which ones to run based on the inputs selected. But before we do that, it is worth noting we should add one extra task here. As you can see, every single time I execute this workflow, it's going to download that original data set. And we're going to just slowly start to run out of storage as we download. In this case, it's not too bad at 50 megabytes, but the yellow data set is much bigger. So to get around this, we should add a purge execution output files task to get rid of these output files at the end, because we don't necessarily want to keep the files, considering we've just put the data into a database, so we don't need the file anymore. So here's my purge files. It's going to purge the current execution files, so it's going to get rid of them before the execution finishes. So if you want to keep them, disable this task, which you can do quite easily by just adding disabled and setting that to true. But in my scenario, I'm going to leave that off because I want it to do that. So we're all ready to go for the yellow data set. There are a few ways that we can get this to work to make sure that we've got tasks that run for the green data set and some that run for the yellow. Now we could go into the task here and underneath the type add a property called run if. Now run if is really useful because I can now just set a simple expression to say inputs.taxi. If I put that inside of some quotes, it will only run this task if we've set it to green, which is important because this has a completely different schema to the yellow data set. But we then have to add this for every task and it gets a little cumbersome. So what we're going to do instead is create an if statement here and then group all of the green tasks together and then do the same for the yellow data set. So it will do all the yellow ones together and all the green ones. And it will make sure that it doesn't accidentally run the green data set when we're running yellow and vice versa. So now we're going to just create a quick ID and we're going to use the flow.if task. And all I've done here is just set the condition to be green. If that's the case, then we want to take all of the tasks that we've just added, other than that purge at the end, and then we want to be able to just indent those in like so. So now they're all indented in and under this block. And if I go to the topology view and we switch it back to this view, you can see now that everything to do with the green data set is now grouped nicely together. And we're always going to run extract the same way because that's just passing the variable into the URL that we're downloading. So that's going to get us the correct file regardless. But all of these are using a slightly different schema and slightly different column names. So this just guarantees that those are going to work correctly. And we're not going to run into any errors due to different mismatch of column names. And the purge files, we're going to purge them regardless of which data set we download. Now with this in mind, what we can do is now add an if yellow and then add all of the same tasks, but modify them to suit the yellow dataset. I've now added all of the tasks for yellow taxis. So here we've got the create table, create staging table, truncate the staging table, copy into the staging table, add a unique ID and a file name, and then merge all the data into that final table. And it's exactly the same for the green. And what it's going to do is it's going to run, check the yellow, check the if statement there. If that if statement is true, it will run yellow. And then once it gets to the underneath, it will check green and go, hang on a minute, green's false, because it's pretty much a Boolean. It can either be one or the other. It can't be both. So that then just prevents any issues there. And then afterwards, it will purge any files that were generated. So now let's run it for the yellow dataset for 2019 January, and we'll see it create two new tables, and it will put the data from the staging table into that main final table too. We can see now that it's copying that data into the staging table from our CSV file, but it's going to take a little bit longer than the green dataset because everything here is about 10 times bigger. And we can actually see if I refresh tables over here, we can actually see that we now have a yellow trip data and a yellow trip data staging. And we can see it's copied the data in, it's now adding those unique IDs for each of the rows, and then it will merge it in to make sure there are no duplicates because we have that unique ID. All our data has now added itself into the database. We can see the purge files has also worked. We can check that out. So if I go to extract and output files, we can see here, it's now 0 bytes. So we're not got any data here. So we're not just every time we run this, just storing that data inside of Kestra unnecessarily. Now, if I go back to our staging data, I can now run a query here to see what's inside of it. We can see very quickly it's taking a while because there's actually some data here. And we'll see the number of rows will update to reflect that too, which is useful. And as we can see, there are over 7 million rows inside of this table. And I can do the same now for the main table as well. And we can see that this as well has all the data from our staging table. So the last example we can do is now just run this for a different month, see all that data combine in the final table. So this time, let's select February, and we're going to let that run in the background. And while that's running, we can see here that the final table, or the main table here, has the same number of rows as the staging. So we can see that both of those have the same number of rows. Very handy. Now we just got to wait for this execution to run, and then we'll get even more data into the final table too. It's finished. Something else that's worth noting, we can see that if green did run, and we can see obviously it was false, so it didn't run any of the additional green tasks. So quite handy to visualize that. Now let's go back into pgAdmin. We can see we had 7 million rows before. If I now run this for the staging table, we'll see that it's going to change. We're going to get a different number of rows, and I can actually copy and paste that so we can do the maths on that to make sure we've got the correct number of rows in the main table too. And there we go. We've now got 7 million rows, slightly different to the other one. So now if we look at the actual yellow trip data table, what we should see is this number of rows at the end. And as we can see, this was the number of rows we were expecting, and we can see that we got the same number. And again, if I go to the last row, we can see that that's using February data, and the beginning is January. What we've achieved here is we've got a number of inputs. This allows us to specify what we want to add to our table. We can specify the data set, and we can specify the year and month too. We can then generate some variables from this, and these variables themselves have expressions in them to allow us to really get creative here and be able to use dynamic information to create the variables so that we don't have to then hard code a load of values throughout the workflow. We then use these 4 different values: file, staging table, table, and data throughout this. And so this makes this nice and straightforward. And by being able to do this, it means we haven't got to hard code it because the file names change, the data names change. This keeps everything straightforward. Afterwards, we then create a label so we can easily see in the execution logs which one ran. So we can see this was yellow, this one was green, and vice versa. We can see that we extract the data by making a request to GitHub using wget and then unzipping that file so that it's ready for us to use, and we can then proceed to use that in our later tasks. We have if statements set up that allow us to decide whether we're running the yellow dataset or the green dataset. This really helps us to break the flow up and make sure we're not running tasks that don't have any data available for them. We're then going to run a load of SQL queries, but the key thing is we're using plugin defaults at the bottom here to make sure we don't have to repeat ourselves for the connection properties needed to talk to the database. This helps to reduce repeating ourselves and makes it really easy to modify the Postgres database that we're using in case we end up using a different one in the future. And at the end, we see that all the data is merged into that table without any duplicates thanks to the unique ID generated using an MD5 hash. Hopefully you found this useful, and this is going to help you create your first ETL pipeline using Kestra. In our next example, we're going to look at doing the same example, but this time we're going to be moving it over to BigQuery in Google Cloud, where we can tap into the power of the cloud to really help us out. Because something I didn't show you is the yellow dataset is much larger, and it's probably going to crash my computer. So we'll use the cloud there to help us out a little bit and speed things up. If you have any questions, let us know in Slack. We'll be checking out the channels to help you out throughout the data engineering Zoomcamp. But again, stay tuned for the next episode and make sure to check out Kestra on GitHub.